In this video, we will tackle another problem that belongs in the Taylor series category. This one's a Maclaurin series problem. It's from the 2015 AP exam, BC question. Okay, so once again, let's read the problem. Let's read all the parts and let's figure out what we need to do. So the first thing is you've been given a Maclaurin series for a function, and you've been given the expansion and all that stuff, good stuff for the function. So here's your series. Uh, You've been told that it converges for some x within some r, where r is the radius of convergence. Okay. First thing is, we're going to use the ratio test to find r. So it tells you what test to use to find r. So that makes life easy. Then you're expected to write down the first four non-zero terms for the series of f prime, which is the derivative of f. Okay, and uh, and then it also wants you to express f prime as a rational function of x. So we'll see what this means as we go along with the problem. And then the last part, it's asking you to obtain an expansion for this e to the x times f of x, and write down a few terms. All right, so straightforward problem. Okay, and let's go ahead and do this. First, we'll use the ratio test to see what we're getting. So what we have is we have this series that the where the general term of the series is essentially this negative 3 times n to the negative 3 to the power n minus 1 over n times x to the n. Okay, and what we'll do is when we do the ratio test, so we'll try to evaluate what the ratio of the n plus 1th term to the nth term looks like. Okay, so here we can rewrite this as n approaching infinity, and then the n plus 1th term would be minus 3 to the power n plus 1 minus 1 over n plus 1 times x to the n plus 1, and then I'm going to divide it by multiply by n over minus 3 to the n minus 1 times x to the n. Okay, and we can just take a look at what the series approaches. Take a look at the absolute value of the series, and what we end up with is this, the infinity. Now when I divide the negative 3 to the n plus 1 term with the other one, all we're left with is negative 3. Okay, and on the other hand, we're left with x from the x to the n plus 1 divided by x, and then we have n over n plus 1, and all this, as you see, will approach 3 times x. Okay, so now for the series to converge, this absolute value of 3 times x has to be less than 1, and which implies that the absolute value of x has to be less than 1 over 3. So the radius of convergence is simply 1 divided by 3. Alright, so we take care of the first part of the problem. Then the second part, it says write down the first 4 non-zero terms of the Maclaurin series for f prime. Okay, so when you're dealing with the derivatives, it's always a good idea to look at a bunch of terms from with the function itself expanded. So what we have is we have x minus 3 half x squared. So for part B, the series looks like where is it? Alright, so let's just call it some Maclaurin series. So it is equal to x minus 3 divided by 2x squared, and then plus we have what is it, 3x cubed minus we have 3 to the power 2, so it's 3 squared, so 9 over 3 times x to the 3. Oh no, we only want the first 3 terms. Let's see, what are we looking for? Sorry, the first 4 non-zero terms. So the fourth term is going to be negative 3 to the power, it's going to be plus minus 3 to the power 4 minus 1 over 3, sorry, over 4 times x to the 4. Okay, so these are the first four terms of the you know of the series itself, and we can write another term just to see what this would look like. So 5 minus 1 over 5 times x to the 5. All right, now we're not interested in this. What we want is we want the derivative of this. So if I were to find the derivative up to the first four terms, okay, then we simply differentiate it term by term. The derivative of x is simply 1, so that's easy. The derivative of x squared is 2x, so the 2 cancels out and I can write this as negative 3x. The derivative of x cubed is 3 times x squared, so the third term becomes 9x squared. The fourth term, okay, happens to be negative uh, 3 to the power 3 over 4x to the 4. And when I differentiate it, we notice that I end up with negative 27x cubed and so on and so forth. Now, if it's asking us also for the general term, what we see, very clearly here is that we have a geometric series, and so the general term would end up becoming negative 3 to the power n x to the power n minus 1. This series, now it also asked here to write down the uh, express this series as a rational function for x less than r. Okay, so if we have a geometric series, we know that within, if the series converges, so the ratio r is obviously equal to negative 3 times x, and we already know that this 3 times x, okay, is less than 1. We know this because it's part of the initial thing where the series has to converge. And since we already know this, we can sum up our geometric series using the formula 1 over 1 minus 3x, which ends up with the function 1 over 1 plus 3x. So this is the rational expression that they were asking. Now, the last part, it says, write the first four non-zero terms of the Maclaurin series for e to the x. So first let's write that down. And then once we have the Maclaurin series for e to the x, then it also wants us to write the third degree Taylor polynomial for g of x, which is e to the x times f of x. Alright, so first let's write down the Maclaurin series for e to the x. So f of x is equal to the e to the x. Now we know that a Maclaurin series, okay, m of x, would be written as f of 0 because it is essentially a Taylor series evaluated about 0. So f of 0 plus f prime of 0 times x plus f double prime of 0 over 2 factorial times x squared plus f triple prime over 3 of 0 over 3 factorial times x cube plus the nth term being fn, oh, not 3, sorry, n factorial over times x to the, what's going on, x to the n plus so on and so forth. So let us evaluate this for e to the x. If the function is e to the x, okay, f of 0 happens to be simply e to the 0, which is 1. So that's easy. F prime at 0 is going to be the derivative of e to the x evaluated, which is simply e to the x, but we're going to evaluate it at x equal to 0, which also happens to be 1. And if we notice, we'll see that all the derivatives of this evaluated, okay, at x equal to 0 will be 1. So my series for e to the x, the Maclaurin series, is equal to 1 plus x squared over 2 factorial plus x cube over 3 factorial plus x to the 4 over 4 factorial plus dot dot dot. Very easy. Now in the second part of the problem, or this part, it wants us to find write the third degree Taylor polynomial for g of x, which is e to the x times f of x. So what we're going to do here is we know the expansion for f of x. F of x is already x minus 3 half x squared plus 3x cubed and so on and so forth. So we'll take that and we will also use the expansion for e to the x and essentially write, combine the two together up to the third degree. Okay, so what we have is, so let's just call it part I for this part. So we want an expansion of e to the x times f of x. E to the x we know is 1 plus x squared over 2 factorial plus x cubed over 3 factorial plus x to the 4 over 4 factorial plus dot dot dot, and we're going to multiply it by f of x, which is equal to x minus, goodness gracious, I can't remember any of these things, 3 half x squared plus 3x cubed minus dot dot dot. So we want this up to the third degree. Okay, so let us simplify. So let's now multiply these things out. You just have to be careful when you multiply this. Okay, so what we'll do is first we'll multiply the 1 times x. And when I multiply 1 times x, I end up with x. So that's my first term. Okay, all other terms are going to be higher powers of x. So the first term is 1 times x. Now for the second term, we have two choices. Okay, so I'm going to use the color blue for the second term. So I can do 1 times this, 3 half x squared, and I can combine x times x. So what I end up with is plus x squared minus 3 half times x squared. So those are the only terms that are of the second power, okay, second degree. Plus, let's do one more term, and for the third term, what I can have, I have a bunch of choices, and let's use the color green for this one. So I can do 1 times 3x cubed, so which gives me 3x cubed. I can multiply the x with this 3x squared term, which will give me negative 3 half x cubed, or we can take this x squared over 2 factorial term and multiply it with x, and we end up with x cubed over 2. So this would be the next term. Okay, so when we combine all this, we end up with x plus 1 minus 3 half is negative half, so this is minus 1 half x squared, and then 3 minus 3 half plus half. Okay, so it's minus 3 half plus half is minus 1, so this ends up becoming plus 2x cubed and plus dot dot dot, and then this is the product, or rather g of x up to the third degree. Right, so that's it for this problem.